Hello friends, welcome to my channel. This is my first video. To I hope to make some more videos. Hopefully this kind of provides um, some of you guys a way to kind of practice while you're looking at different videos, trying to find out different ways of doing the same problems. So with that said, we're going to look at a really easy problem. It's defined as easy on LeetCode. So this one says reverse a linked list. Right? Reversing a linked list, essentially, you're given like a list of list nodes um, in a particular order. And what this really says is just reverse them so that for example, in this case, the next node of 2 should point to 1, the next node of 3 should point to 2, and so on. As you can see, this is a pretty popular question. It's asked by most of the companies like Amazon, Apple, Microsoft, Google, Facebook, all of them seem to like this question. Now, one thing to note is even though it's an easy problem as categorized on LeetCode, really why I think some of the easy problems are important to look at and really practice is because this will these are essentially building blocks that will that will allow you to practice and get better at more like the medium and the hard level problems. Linked list is a data structure that is pretty common in the interview questions. And if you've been practicing for a while, or if you've just started practicing algorithms for interview questions, you'll notice that there'll be a lot of linked list kind of questions. So if you can master some of the easy ones like a reverse linked list, not only is it going to give you confidence in solving the medium ones, but there are some which actually implement linked list or reversing the linked list as part of the solution. So with that said, let's kind of look at a little visual representation of what this linked list looks like, right? So let's take this as our initial input, where we have two nodes. This nodes 1 points to 2, 2 points to null, right? So what we would do is, the algorithm is going to be pretty straightforward. We define a null node called prev, right? Don't do anything with it. And then the head of our linked list, which is 1, we call it current, okay? So we define a new list node, call it current, and that make it the head. Now what do we do? So we essentially just need 4 steps that we need to iteratively keep doing till our current becomes null. So what are the 4 steps? The first step is let's define a next node, right? So the node next to the current, so current.next, let's call it the next node, all right? So that once we take the current.next pointer and change it, we don't lose context of what the next node is, right? So now we have a next node. That's step 1. Step 2 would then be change the current node's next pointer to point to the prev node, right? So current.next become prev. That's our second step. The third step at that point says, okay, so now let's move prev and set it to the previously current node, right? So what we do is essentially take prev, set it to current, right? So now this becomes our prev node. And then lastly, the fourth step is going to be, remember we'd set the next node. So what we do is we change our current node to the next node, right? So this is the state that our linked list gets to after our first iteration. Now, when you repeat that iteration again, let's do it. In this case, what we do is this becomes our next node because this is current.next, right? Current's next pointer points to prev. Prev becomes the node which was current earlier, and then current becomes the next node, right? This was the next node, and then current becomes this. And now that it's null, we're done. We get out of the loop, and then what do we return? We return the prev node. The prev node is this. So when you look at this, this essentially is the reverse of the original, right? 2 points to 1, 1 points to null. This essentially is the reverse of the original linked list. So with that understanding, let's go and really write out our algorithm. So remember, we need a prev node. So let's call the prev node and then set it to null initially. Also set the current node to our head node, right? So these are the only two list nodes that we need to define. So now remember, we need to do this iteratively. So we do a while loop while current not equal to null. We do something, right? So what do we need to do here? Remember the 4 steps. We need to define a next node, and that is set to the next node of the current node, right? Step 2 was we set the next pointer of the current node to the previous node. Step 3 was we set prev to the current node. And then lastly, your current node is set to, remember we kept a pointer to what the next one was, we set it next. So once we do this iteratively till current becomes null, at that point, all we have to do is return the prev node. At this point, our linked list is reversed. And I'll go ahead and run this code. It works fine. Let's submit it. There you go. The runtime is pretty good. Memory usage, again, here it's relative to the algorithms of other users. Now you could essentially not define a current node. You could essentially continue using the head node, and that would save a little bit of memory. So it really is an implementation thing. So with that said, I hope you enjoyed this video. Again, this is probably one of my first videos. I hope to improve in the upcoming videos, and I hope you guys continue to watch my videos. Thank you.